Homework 13, question 6. We've got a lot of information in this question. We've got a format for our equation, d equals a plus b sine kt, three constants that we need to find, t is time in days, after the spring equinox. So in part A, we're told that assuming the number of hours of daylight follows an annual cycle of 365 days, find the value of k, giving your answer correct 3 decimal places. So we want the entire trig function to range between 0 and 365 as opposed to the 0 and 360 that a function normally would do. So we want to be starting at 0 when t is equal to 0, and we also want to be finishing at 0 when t is equal to 365, as if it was getting sine of 360. What this means is when we plug in 365, we want k times 365 to be equal to 360. A little bit of rearrangement gives us k equals 360 over 365. Now in part B, we're given the shortest and longest days, 6 and 18 hours respectively. That's our maximum and our minimum value for our trigonometric functions. Our maximum value is still going to occur when we have sine kt equal to 1, and therefore that value of d, 18, will come from a plus b. Our minimum value is going to occur when sine kt is equal to minus 1, and so that minimum value of d equals 6 is equal to a minus b. And this is a pair of simultaneous equations that we have to solve. If we add the two of them together, we get 24 is equal to 2a, so a is equal to 12. And if we do the first one, take away the second one, then we get 12 is equal to 2b, and we get b is equal to 6. So in part C, we're told to find in hours and minutes the amount of daylight on New Year's Day 80 days before the spring equinox. We can either go with t equals minus 80 for this particular question, or we can take away 80 from 365 and work with a value of t of 285. I'm going to go with the minus 80 option here. So I've plugged in my values of a, b, t and k into this equation, and I stick that into a calculator, and that gives me 6.11 hours. However, I want this in terms of hours and minutes, so I want to take the 0.1122 part of my answer and times that by 60, and that gets me 6 hours and 6.73 minutes. That I would personally round up to 6 hours and 7 minutes, but 6 hours and 6 minutes would also be an acceptable answer. When you're asked for a time in hours and minutes, it is important to finish it off, but it is well worth giving this time as a decimal amount of hours beforehand, because that's needed to work out the hours and minutes. That might sometimes be enough to get the full marks, but it certainly will be worth a mark in its own right, and then possibly the one to follow afterwards. In part D, we need to find the times of the year where there is exactly 10 hours of daylight. Now it's likely to lead to a decimal day for our answer, because that's how trigonometric questions work, and that will give us a little bit of flexibility as to whether we round up or round down on our final answer, because it is not going to give us an integer answer. There is no day with exactly 10 hours of daylight, but we can say it's either this one or this one, whichever one gets closest to it. Either way, we need to start with d equals 10, and so I've plugged that value plus my values of a, b and k into the equation, and I'm trying to solve this equation for t. Now, both to save writing and to make this look a little bit neater, I'm going to be using the substitution phi equals 360t over 365, and using this substitution on my limits, I'm going to solve the equation of phi between 360 and 0. So I'm essentially solving a normal trig problem. If I take away 12 and divide by 6 and simplify, my equation actually becomes minus a third equals sine phi. And so I take the inverse sine of minus a third. The first answer I get from my calculator is minus 19.47. That's outside my range of values for phi that will work for me, but I can use that. If I take that away from 180, that gives me 199.47. And if I add 360 to it, that gives me 340.53. But I didn't want phi, I wanted t. So I need to take these answers, times them by 365, and divide them by 360. I'm not going to do it to this first one, but if I do that to the 199.47, that gives me 202.2. And if I do it to the 340.53, that gives me 345.3. However, I was asked for days, so I don't want to give a decimal day. I want to round up or down. I'm going to round down because they're both getting closer, but the answers, if you had rounded up, would have been acceptable. So it's the 202nd day after the spring equinox, or the 345th day.